In question 6, we're told figure 3 shows a sketch of part of a curve C with equation y is equal to x multiplied by x plus 4 multiplied by x minus 2. The curve C crosses the x-axis at the origin O and the points A and B. In part A, for 1 mark, we need to write down the x-coordinates of the points A and B. The x-coordinates will be where y is equal to 0. So we can write now 0 will be equal to x multiplied by x plus 4 multiplied by x minus 2. If we go ahead and solve this, we can see that x is equal to 0, which is the origin, x is equal to minus 4, which is A, or x is equal to 2, which is B. I'm going to write now that A has the coordinates minus 4, 0, and B has the coordinates 2, 0. We're only asked for the x coordinates, so we can say A is minus 4 and B is 2. We're now told the finite region shown shaded in figure 3 is bounded by the curve C and the x-axis. In part B, for 7 marks, we need to use integration to find the total area of the finite region shown shaded in figure 3. What I'm going to do now is take the integral from minus 4 to 0 and add it to the integral from 0 to 2. When I add it, I need to ensure that I'm taking the modulus, or the absolute value of my integral, as this is going to give me a negative value as it's below the x-axis. So what I'm going to do is state that this is going to be area 1 and this is going to be area 2. So I'm going to have now the integral from minus 4, which is the x-coordinate of A, to 0, and we can write minus 4 to 0 of y with respect to x. I'm going to add to that now the integral from 0 to 2 of y with respect to x, and take now the modulus of that, the absolute value. This point is 2, 0. So if I just add these two together, I'm going to have now area 1 and area 2. I've got y is equal to x multiplied by x plus 4 multiplied by x minus 2. With the skills that we have, we're going to have to multiply this out and then integrate. So I'm going to write y is equal to x, expanding the double brackets, x squared plus 2x minus 8. Multiplying through by x, y will be equal to x cubed plus 2x squared minus 8x. So if we start off now with area number 1, we can say now that area number 1 will be equal to the integral, and we're taking this from minus 4 to 0 of x cubed plus 2x squared minus 8x, and we're integrating with respect to x. So we can say now that the area 1 is going to be now, and I'm just going to write this out, we're going to have 1/4 x to the 4th. I've raised by a power and divided by the new power. Raised by a power and divide by the new power, so 2/3 x cubed. Raised by a power and divide by the new power, so we're going to have minus 4x squared. We're interested in this now from minus 4 to 0. We can then say that now A2, and just writing it down here, will be the modulus of, and we're integrating, we've got 1/4 x to the 4th plus 2/3 x cubed minus 4x squared, and we're interested in this from 0 to 2. So all I'm going to do is add these two together. So let's go ahead and evaluate and then add them up. So we'll have area number 1. So area number 1 will have now 0 plus 0 plus 0, and then we need to subtract away. I'm now going to evaluate minus 4. If I take minus 4 to the 4th power, that's going to give me positive 256. So we'll have 1/4 of 256. Then I'm going to have plus 2/3 of minus 4 to the power of 3, which is going to be minus 64. I'm then going to add or subtract from this minus 4 lots of minus 4 squared, which is going to give me now minus 16. So we end up now trying to, we will find this, and we can simply write that A1 will be equal to 0. We've got 64 here, we've got 64 there, they're going to cancel, so this will be minus and then we're going to have minus 128 over 3. So minus 128 over 3. So that gives me now the value of A1 is 128 over 3. Let's go ahead now and look at the modulus of A2. The A2 is going to give me now, subbing in the 2, we're going to have 1/4 of 2 to the power 4, which is going to be 16. We're going to have plus 2/3, 2 to the power 3, which is going to give me 8. And then we're going to have now minus 4 lots of 2 to the power of 2, which is going to give me 4. So just subbing this in. Then we got 0, so we'll subtract away 0, plus 0, plus 0. So if we look at this now, what we have, A2 will be the modulus now. We need to take the modulus of this. This is going to be 4, and then we're going to have now plus 16 over 3 minus 16. So this is going to give us now 16 over 3 minus 12, which will give us minus 20 over 3. So we need to take the modulus of this, so we can say now that A2 will be equal to 20 over 3. So A1 plus A2, that's going to give us now 128 over 3 plus now the 20 over 3, which is 148 over 3. So that now is my final answer for the finite region that's enclosed now between C and the x-axis.